All right, Richard, let's summarize what laser drying in terms of battery technology can do for the battery and just EV industry. But first off, who are you and who is Laserline?
First off, thanks for being here. Thanks for taking the time. I'm Richard and do business development at Laserline. Laserline is a pioneer and market leader in high-power diode lasers in a variety of industries, one being industrial battery manufacturing.
Mm-hmm. Okay. So in terms of laser drying, what are the big advantages that you see?
Well, let's go back to where the drying of battery foil comes from. Mm-hmm. So it's convective ovens, which grew to now up to 100 meter lengths at up to 100 meter per minute speed. So technical monsters of machines, which then are placed like 10 next to each other and can be in a building as large as a football field.
Yeah, because you want to have the high speed of coating, and that is why, because you just can't bring so much energy in. So that is the reason why you have such long tunnels, right? And exactly. That's just a very, very large footprint of the drying tunnel then.
And the battery slurry needs to be dried in a cautious way, right? You can't instantly get the water or NMP vapor out. Yes. If you try to increase that too much, you will tamper with the quality. Mm-hmm. So
like skin formation on the coating surface, for example, or binder migration?
Those are the two keywords, yeah. Mm-hmm. If you go too fast. And that's true both for IR drying methods as well as convective drying methods.
Gotcha. On the front of research industry collaboration, or to push the laser technology and laser drying technology forward, what did you do so far?
Well, what has been done, and it was an idea in various R&D circles and industrial circles between around 2015, 16, 17, is to enhance the drying process by means of diode lasers. Okay. So to get to the state where we are today, there was a 3-year research project between PEM.
You mean the IDEEL project?
The IDEEL project. Yeah. Laserline, a number of Fraunhofer Institutes and industrial partners, who were heading out to show that diode laser can be a qualitative and also a true business alternative.
So economically viable in the end?
Exactly. Mm. And through the project, what turned out to be the best option to balance between quality enhancement and cost reduction is what we call the booster concept. That means at the beginning of the drying process, you ramp up the temperature profile of the battery slowly a lot faster, and then continue in the conventional drying oven. Yeah, that is a visual of the drying process. What you see here is the top height profile of an IR laser. What you see in that sequence is the state change between wet and dry.
So just in repeat, so that's the top view with the IR camera, and then here we have the normal side view in which you just see like a person would see it, so the laser is not visible, right? So this is a project, or actually this is footage from the IDEEL project, which was conducted here at eLab together with PEM on our pilot line at SelfHub. Yeah. If you compare the technologies and should point out at some KPIs, which would be the KPIs that you would mention that are improved by means of introducing laser technology to battery manufacturing?
Laser drying in battery
In one
foil
sentence.
production will reduce CapEx by roughly 20%. That is mainly fostered by the reduced floor space of very expensive clean room. And the OpEx roughly by 30%, fostered by less energy consumption.
And finally, I want to state a critical question. The battery production technology is evolving towards dry or, in the intermediate step, semi-dry coating. How do you see that from your perspective as a laser manufacturer being involved in drying solvent-based coatings? So is there a market for you in the future?
There is a market in the future. The business perspective for wet coating is probably around about 50% market share in 2030. That
According
is still
to whom?
According to the latest Porsche Consulting predictions.
Okay.
And it is a somewhat likely scenario.
Okay.
Also assuming that wet coating will make progresses, right? And laser drying is one of these ingredients that will make it more effective and ultimately lower cost for the manufacturers.
So you see...
But
yes.
to the other part of the question, semi-dry and dry coating isn't cold coating. They also need energy to warm the ingredients up. And there's a number of good approaches to also use lasers in these processes.
Yeah, due to the controllability that we talked earlier about, for example?
For example, that. But you get it to the point of action where you want it to be. And you usually have somewhat of a volume absorption of the energy by using photons.
All right. So I would say I'm looking forward to all the innovation that you will come up with in the future. And then our next conversation on that status then. Thank you,
Thanks
Richard.
a lot.
Thank you very much
Thanks
for
to
the
you.
conversation.